everyone and welcome back. In this video I'm going to be doing another example of some trig graphs. In this case we're going to be looking at the format as shown below. We've got y equals a sine theta plus some constant. Okay, so let's take a look at an example of this form. So here we've got sketch y equals 1 sine theta plus 2, which is the same as we had before with the format where we had y equals a sine theta. So we had that before with that's the amplitude, and now we've got an extra 2 there. Okay, so that's just a constant. Okay, so what we do, same as always, first step, we need to get some points so we can plot this graph. So I've filled in the points below, but basically how we get them, same as before, we plug in different values for theta. So we have y equals 1 sine theta plus 2. If we plug in 0, we get y equals 1 sine of 0 plus 2, which is equal to sine of 0 is 0 times 1 is 0. So we've got 0 plus 2 equals 2, which is how I got this value here. Okay, so you do that with your calculator, just plug in all those values to get this table. Okay, once we've got this table, we can start plotting the values on our graph. Okay, so we quickly plot them. We've got a 2 there, a 3 at 90, a 2 at 180, then at 270 we've got 1, and then we've got a 2 again. Okay, so we draw our curve as always using some smooth curves, and we get a shape like that. Okay, so what's interesting about this is it looks exactly the same as the sine curve that we had before. So before we had the sine curve, it looked like that. We've got the same shape here. The only thing is it's been shifted up. Okay, so if we look at the sine curve on this one here, we have 0 point is at 0, 0, whereas here we've got it at 0, 2. So it's shifted up 2 units. The same for the maximum point. So the maximum point here on the normal sine theta, we've got y equals 1. Here the maximum has shifted to y equals 3. So it's also again an increase of plus 2. Okay. Okay, so now we've completed step 1, we've sketched our graph, we need to start interpreting it. So the domain, as before, was given in the question, so we know it's the same as we've been working with, it's from 0 to 360. Okay, so that stays the same, even though we have this 1 here and that plus 2. To get the range, we first need the maximum and the minimum y value, so let's do that quickly. So our maximum y value is here at 3, so that means y equals 3, and the minimum y value is here at 1, so y equals 1 is our minimum y value. So that means our range of y values is from 1 to 3. Okay, so that's quite different from what we had before, where usually with the sine theta graph, we just have from -1 to 1. Okay, so what that tells us is that when we add a constant to the end of this function, it actually shifts our y values and our range. Okay, let's see at the effect on the amplitude. So if we look at the amplitude, generally we define it as the height from the x-axis to the maximum value, but if we look at this one, technically we can say our x-axis is here in line with that, sort of like that. So it ranges from 2 to 3. So that means our height is 1 for our amplitude. And this actually matches what we have in our function here with the 1, where we said that this value in the front there is actually our amplitude, which is good because it means we are right in the last video. So our amplitude is 1. You can see also if you look here from this point down to the trough, it's also going to be 1 because it goes from 2 to 1. Okay, so amplitude is 1. Please ask me questions if you are uncertain about that one. Next up we have the period. So the period, same as always, it ranges from 0, where the start of the wave, to the end of the wave at 360, so that's that range there. So our period is 360. So basically, what we see is when we add a constant to the end, it actually only changes the y values because it shifts it up, shifts it down. So what we call it is, we say y equals a sine theta plus q. Okay, so now we know that is the amplitude. So even when you move it up, move it down, the height of the wave remains the same. So that's your amplitude. And what we call that is a vertical shift. So in conclusion, from these few examples that we've done in these videos, when you get a function and it's in this form, if you have an a value in the front here, any sort of constant, that's going to be your amplitude. Remember, it's always positive because it's a height. And even if it's shifted up, it's always the height of the actual wave, not the distance necessarily all the way down to the x-axis. And for q, that's your vertical shift. It's any constant, and it moves your normal graph up or down along the y-axis. If you have any questions, please let me know. If you have any other examples you'd like me to do, I'd also be more than willing. Thanks for watching.